Okay, time's up, and so I'll begin. Today I'm going to talk to y'all about insights into the late Triassic from the Elliott Formation of South Africa at Kameha Village. And though for those of you who don't know me, I'm Jonah Choiniere, and I'm an American originally, but I've moved to South Africa 11 years ago, and since then I've been at the University of the Witwatersrand's Evolutionary Studies Institute. And this beautiful vista that you can see at the top of this slide is on the approach road to this lovely sort of happy place for me in South Africa's Eastern Cape province. Before I, well, let's see if this works. All right. So before I launch into kind of the specifics of the paleontology, I just wanted to, for those of you who didn't know me, to tell you a bit about my own background. I grew up in Massachusetts, in the rural part of the center of the state. And I grew up on this amazing place. It's a Massachusetts Audubon Society sanctuary called Wachusett Meadow. And it's about 1,400 acres of rolling fields and beaver dams and old barns, some of which date to the 1700s. And as a kid, I mean, this was an inspirational place to grow up. Basically, the whole world was my backyard. And I had it sort of fostered a love of being outside and exploring the natural world. And that really pushed me into the natural sciences. And so when I was choosing graduate schools and things that I was going to do with the rest of my life, I really wanted to look for a program that had a strong field component. And I was lucky enough to go to George Washington University and get hooked up with Jim Clark's research group and ultimately many other research groups networked through him. And since then, I've been undertaking some really big field projects out to Xinjiang and the Shishigu Formation, the Mongolian American expedition with the American Museum, and work in the northeast part of China, as well as here in South Africa and in the neighboring country of Zimbabwe on the upper left, doing little prospecting around the shores of Lake Kariba. And these big field projects are really, well, they're what drives me. I just love collecting vertebrate fossils, and I love getting stuck in and trying to figure out, regional stratigraphy and how all the fossils fit into sort of a biostratigraphic picture. And that sort of love and experience with big field projects is what drew me to apply to the job at the University of Witwatersrand 12 years ago when I applied. And it's led me to work in this place. This beautiful vista is showcasing outcrops of the Elliott Formation of Southern Africa. So it's got outcrops in South Africa and in Lesotho, and then contemporaneous or stratigraphically equivalent stuff up through into Zimbabwe, possibly Zambia and Namibia. And the Elliott Formation of Southern Africa is it's just a magical place. It's been known for more than 150 years. There have been luminaries who in the field of vertebrate paleontology have worked here, people like Thomas Huxley and Sir Richard Owen, enabled by collectors like Joseph Orpin and Hoha Brown. So it has this tremendous history of discovery and fossil collection that's really, quite proud to be a part of. And as you look at the Elliott Formation and its outcrops in South Africa, it's can be divided sort of lithostratigraphically into a lower portion, which you can see in purple here, and an upper Elliott portion, which is in a brick or red. And together, those used to be called the red beds. And then above that, in sort of stratigraphically continuous with the Elliott Formation, is what's known as the Clarence Formation. It's a increasing arid environment where dunes were sweeping across the landscape, much like Namibia today. And then this whole sedimentary package is capped by the Drakensberg group, enormous flood basalts that went all the way across Antarctica and into the western portion of Australia. Those Elliott Formation outcrops are what we're going to focus on today, and we generally think that the timing of the stratigraphy is divided such that the lower part of the Elliott Formation is Triassic, and then the upper Elliott Formation into the Clarence and Drakensberg groups are Jurassic. Because of that tremendous exploratory history of the Elliott Formation, we actually have a really sort of superb sequence for understanding the transition between the Triassic and the Jurassic. And you guys will, of course, know that there's a large, one of the big 5 mass extinctions happens at that boundary. And that evidence which we summed up in a recent paper, the Bordy et al. 2020 paper, comes from all parts of sort of the paleontological toolkit. So if you look at this chart here, which shows you stratigraphic ages on the left, we managed in the first column, we've managed to get a number of detrital zircon-based radiometric dates for the Elliott Formation, which reinforce this Triassic-Jurassic division. And the work of 150 years has given us a pretty decent biostratigraphic resolution on the Elliott Formation. And we have a noticeable shift in the faunas from the lower Triassic portion up into the upper Jurassic portion, and more on that in just a second. There's also work that's still active, but was pioneering in the 1950s and 60s and 70s by researchers based in Lesotho on the ichnites of the Elliott Formation. And so we have a really good tetrapod footprint fauna that spans the entire fossiliferous sequence. And more recently, Emma Bordy and her research group have been able to get magneto and lithostratigraphy sort of nailed for the Elliott. So, I would say, if you're going to come to the Elliott, you're entering into a space that's one of the best understood Triassic to Jurassic continental sequences in the world. Now, that isn't to say that it's without problems. And one of the biggest issues that we have in understanding the Elliott, and it's significance for vertebrate evolution, is the fact that there's highly variable sampling densities in its different strata. And I won't talk about the clarins, but if you look down the column from top to bottom, the clarins sitting on top, we have about 53 known vertebrate fossils, 53 known vertebrate specimens from it. The upper Elliott Formation has nearly 1,000. Actually, it's probably well over 1,000 now since I wrote these figures down. And the lower Elliott Formation, the Triassic part of the column, only has about 275 fossils, many of which are essentially rubble. They're very hard to diagnose to the genus level, and sometimes even to the major group of dinosaur level or something like that. And so this poses a problem, right? If we want to understand this transition from the Triassic to the Jurassic and make some hypotheses about what went extinct at the end Triassic extinction, we're really sort of depauperate invertebrate fossils from the lower Elliott Formation, and it hampers our ability to make informed hypotheses about what happened there. And so when I started at Wits University here, it was pretty clear that my first goal should be to go out into the lower Elliott Formation and try to address this bias in collections. I'm just going to double check the chat and make sure I'm not, okay, good. I'm not doing anything wrong. You guys can hear me well. And that's what brought me to this magical place, Kameha village in the Eastern Cape province. This is what it looks like from a distance. On the left, it's a rural area of South Africa, tucked right up against the corner of Lesotho on its southwest corner. It has a number of small settlements. Many people are either regional or subsistence farmers. And there's small populations and villages like this spread out throughout this part of South Africa. On the right, you can see where it is. Johannesburg's, where I'm sitting right now, is marked in black in this sort of green outline of South Africa, and it's about 600 kilometers due south of Joburg, and like I said, right there on the Lesotho boundary. So the outcrops at Kameha village show a mixture of Elliott Formation strata. Most amazingly, they have wonderful exposures of the lower Elliott Formation. But I wouldn't have shown up at this remote place if it weren't for if it weren't for these people. In 2016, I was sitting in my office, and one of my colleagues brought in some fossils. They weren't much to look at, but there are a few interesting bits of sauropodomorphs and things. And she said, I was given these by a student in my department. She thinks they're fossils, and if you think they're fossils, she'd like you to call this guy on the right. His name is David May. And David May is a director of curriculum in the greater Kameha community, and he had received the fossils from the man on the left, a local shepherd with absolutely no education past elementary school, whose name is Dumangwe Tayobeka. And Dumangwe is out every day herding his sheep, walking the land, and occasionally he would run into large vertebrate fossils, and he thought maybe these were something important. So Dumangwe, the local shepherd, who we really call a community pioneer now, relayed these fossils to people in the know, and by an incredible series of coincidences, they landed on my desk. And in 2017, I called these guys and I said, look, we're going to be in the area. We'll pop by for a day visit and see what you found. And at that time, I was out on separate field work with Richard Butler and his students, also pictured here. And so we drove the long dirt road to get to Komeha, and we met this guy on the upper left. His name is Skinyane Halane, and Skinyane is he's a Jehovah's Witness preacher, also a person who walks from community to community, teaching sermons and doing religious studies. And he had advised Dumangwe, the shepherd, that these were in fact quite old bones, and they might represent life of the past. And you can see him in his beautiful stone house here, and he's showing us the collection of material he had found in the area. So we showed up. I didn't expect much based on the material that was given to me, and we spread out across the landscape to search for fossils. And this, at the bottom strip here, is the first site that Skinyane and Dumangwe showed us, and every star maps a place where we ended up building a quarry. It was incredibly fossiliferous. What we discovered is that these community pioneers had found a sort of a virtual dinosaur graveyard, if you will, in the lower Elliott. And just with the fossils marked in yellow here by stars, we could tell that they were going to have a great effect on enriching this lower Elliott Triassic fauna. So it was pretty exciting. Basically one of the most exciting paleontological days of my life. I literally was walking on air coming back from this. They showed us something like 25 additional sites that day, and we left Komeha in the evening thinking this is going to be a project that carries us to the rest of our careers, which so far is true. I just want to show you the spread of those fossils. This is in the center. You can see a red dot says Komeha bone bed, but each one of these yellow dots is another place where we found things that are significant and have either finished the collections thereof or are still working on building jackets, getting specimens out of the ground. And so you can see quite quickly that these significant lower Elliott fossils are spread out over sort of a 4-kilometer square with the densest concentrations within sort of separable localities where we have different quarries. Well, I knew that the magnitude of the material we were going to collect would sort of outpace my ability to study it. And once we got back, Richard and I got back from the field, we just decided, look, we're going to call as many paleontologists who are active in Southern Africa as we can to see if we could build a research team that could best study these fossils. And this is really my first experience doing it. It wasn't always easy, I guess, is the thing. But we wanted to make sure that we got a lot of scientists involved so that there was no aspect of the possible sort of research endeavor that was understudied in the end. So in the end, we recruited all of these people who you see, Roger Benson and Paul Barrett, Selena Suarez, Pia Viglietti, Lara Shishio, Emma Shabordi, Jen Botha, who's now with us at FITS, and a number of other people that I didn't have space to provide photographs of. And together we've sort of formed an alliance or brain trust, if you will, about how best to go about getting the most research out of Komeha that's possible. Well, interestingly, you go to a rural place like this and you think, oh, these people might be a little less connected to the wide world. But interestingly, one of the people in the village, his daughter works for the BBC. And of course, the community pioneers were so excited when we left, and we're all talking, oh, how are we going to make this great? And so this woman from the village, who's now a BBC reporter, caught wind of this, and she wrote this article about how did a South African shepherd find a dinosaur graveyard. And you see that there's quotes from Skinyane and Dumangwe on the left. And once this got out in the news, it got hot quick. And so when I returned the following year to start doing excavations, I immediately ran into some permitting issues. The South African sort of paleo research environment operates in a space where we have strong national legislation that makes all fossils are essentially property of the state. They belong to all the people of the country as national treasures. And as such, the collection of vertebrate fossils is regulated by the South African Heritage Resources Agency. That agency sort of spins out that authority to the provinces. So the Eastern Cape Provincial Heritage Resources Authority is part of that legislation and part of that regulatory body as well. And they weren't too happy that I was working in Kameha. What I had done is applied with them for permits, and they were in a period of transition, and that application never got through. And I waited 6 months for the permits, but never got them. And I decided, well, I'm going to go and dig anyway. And they called me and said, we're going to send the police there to stop this. And I explained the situation. And luckily, because of some very flexible people who are, quite forward thinking, they said, look, you can carry on, but we're going to have to sort out this permitting issue as soon as you're back. I wanted to just point out that, and this sort of foreshadows stuff I'm going to talk about later, that these heritage resources authorities, they're a bit like the U.S. National Park Service. They view the cultural resources landscape, as they say, as not only sort of a collection designed to forward the scientific goals of the country, but as a collection that can leverage community development, that is income either through sustainable means such as tourism or things like that. And so that mandate isn't strictly science. And as a part of getting this permit, I had to talk to them about what my plan was to empower the community and to make it a better place to live and possibly make some more jobs. But I'll tell you a bit more about that later. Well, I want to show you the first quarries that we opened up. This is what we call on the left, the upper quarry and the lower quarry. And you can see that they turned into pretty large bone beds. In both cases, these turned out to be sauropodomorph dinosaurs. But these are 2 meters up to 3 meters in length on an edge, and resulted in blocks that are sort of the size of a grand piano in some cases. And they're big and heavy, and this is something that my training in paleo didn't really prepare me for, was how to tackle such monstrous jackets. So these jackets and collecting there posed some logistical challenges that I had never sorted before. And in the end, I luckily was able to meet with contractors that I got through local people in the village. And we designed methods for flipping these jackets, for hoisting them onto trucks and getting them back to Joburg so we could study them in the lab. Those logistical challenges extended to other items of scale. So how do you make a map of an area that's so big? And we luckily partnered with a student who's doing his PhD on imaging and auto classification of the landscape using drones. And he was able to map some of our field areas at sort of incredible scales, at almost 1 kilometer long by 0.5 kilometer wide, at like 1 centimeter. So you can zoom in on individual pebbles. This is technology that was totally new to me at the start of the project and is now sort of something I would incorporate into my field work, for pretty much every project in the future. And then, of course, when we got some of these fossils back to the lab, we couldn't get them through the doors. We had to build a custom laboratory with, sort of remote prep stuff. With separate dust separator, separate compressor. We had to custom weld trolleys that could support the great weight of these things. And then we had Mark Graham come down from the Natural History Museum in London and teach us how to make an archival jacket for a specimen that weighs 1,000 kgs. And so all these things were logistical challenges that if you have questions about, how do I solve this in my field project, I'm happy to talk to you at the end about that, or refer you to the Grand Masters who taught me how to do this stuff in passing during the development of the project. Okay, well, that's sort of the background. I'm going to come back to some of the stuff that goes beyond paleontology at the end of the talk, but I want to show you some of the fossils we've retrieved from there because they're just so exciting to me. And so that let me just go back a second and show you that upper quarry there on the left, which you can see a couple kind of crummy bones popping out of. That became a gigantic disarticulated skeleton of a new sauropodomorph species. And my student Atashni Mupin's just finished her MSc describing this thing. There's a bit of a topographic SDL model in the center of what that jacket looked like when it was prepared. And we got a giant humerus, a giant tibia, a giant ilia, and a variety of other bones out of that quarry, all of which seemed to pertain to one animal. And so we're quite chuffed on our first sort of strike to find something that doesn't really resemble any of the other lower Elliott sauropodomorphs that we knew before we started the project. We also got fossils of things that we did know, but didn't know perhaps well enough. This is an animal called Scalenodontoides. It's a traversidont gomphidont, so it's on the cynodont tree, pretty close to the origins of mammals. And that's a specimen that's been known from several skulls around the country. But we actually ended up with some postcrania for this animal, and that's being studied by Christian Kammerer and a student in our department, Brandon Stewart, right now. The postcrania tell us that it had a very large head for its body size, not surprising in that part of the tree. But also we could get a body mass for this animal, and it's sort of a lion-sized cynodont, which is cool to think about in the late Triassic of South Africa. It also has this enormous caniniform. I thought it was a theropod tooth when we first found it because it has serrations. It's mediolaterally compressed, super zyphodont. But they're gomphidont, so they have sort of chewing dentition in the back. But they must have had some sort of impressive display structure that or display behavior that they're using these large teeth for. We also uncovered the first skull of a Triassic sauropodomorph from South Africa. The skulls are like hen's teeth down in the lower parts of the formation. We just didn't seem to get them before. And on the left-hand side, I'll put an eyeball there so you can see it. You can see we got a beautiful half of the skull and a nodule, and we've got a few more pieces of that nodule now by repeated collecting. That went to the synchrotron in Grenoble, France, and Tashni has carried on her studies from the big sauropodomorph, and she's just segmented it all out. And of course, it's a new species, and it's somewhere near Massaspondyllidae on the tree. Not quite sure where it goes. It's also got great postcrania, including some vertebrae and limb bones that we've been able to get histological sections out of. Now, so that's just a smattering of sort of fossils from the Kameha area that we know what they are. There's about 400 fossils we've collected, all things told. But the most special quarry in the area is here, and I want to spend a little time and tell you what we've retrieved from there. I've given snippets in other talks, and I think summing it all up should be quite impressive. But one of my PhD students at the time, a woman named Kathleen Dolman, was wandering with Elsa Pancharoli on the side of this stream. They're feeling perhaps a bit dry after a late evening, and they stumbled upon just a low cliff full of soft sediment that just had bones weathering out everywhere. And we call that because of this bridge, we call it the Big Bridge Quarry. We excavated that Big Bridge Quarry. There it is on the left. When we started excavating in 2019, and carried on making some big jackets. I'll tell you what's in those jackets in just a second. Carried on making big jackets in 2000 at the end of 2019, and skipped a couple years because of COVID, and started again in 2022. And then finally, just this May, we were able to crane out the rest of the big material that we had discovered there, and it's all sitting back in my lab, and we've been prepping it quite rapidly. So this quarry is pretty much the best quarry you could possibly imagine. It's in the lower Elliott formation, so it's Triassic in the undersampled part of the column. It's in the softest matrix. You can just gouge it with a screwdriver. It's sort of a clay, and the bones are quite resistant and hard. It's got a beautiful babbling brook next to it. It's got easy access to the main road. We could drive a crane truck here. We could drive a backhoe there. And a bit sad to see that quarry wrap up, because I may never find something that good again in my lifetime. So anyway, we pulled all these jackets back, and we got a bit more than 6 tons of fossil material. And as we prepped it, it's shown an incredible diversity of animals. Come, you do it right. Okay, so that was the quarry on sort of day one as we just flattened it out. And these labels include all the cool stuff we found from it. So we've got some unknown small vertebrate stuff, some that we know what it is now. a Rawasuchian skull. I'm not sure where that thing goes on the tree, but it's close to Postosuchus and maybe close to early crocs, things like Carnifex. We've got several theropod postcranial elements. There's a sauropodomorph in there, and there's some dinosaur morph stuff, possibly Silosaur. And I'm just going to show you what that material looks like now, as just a little bit of paleo bragging. So first, let me just show you the large Pseudasuchian. I think it's a Rawasuchid, or possibly just an earliest crocodilomorph. That specimen was nearly completely articulated, extending all the way along the outcrop, with a skull on the left, articulated dorsal vertebrae, and a hip, and an articulated tail at the end. And the leg was slightly jumbled up. That material looks like this. So far we've been able to prep from left to right some brain case material, some lower jaw material, a little bit of the lateral skull, that's a jugal there. We've got into the center now, we've got some very nice articulated osteoderms. They're super elongate and smooth. We've got both the ischia. The rest of these are still in a jacket being prepared. We've got a beautiful partial foot heading to the right, and on the rightmost edge, we've got a tibia and fibula. We also have a variety of the caudal vertebrae prepped out in this big pubis at the very bottom. So this animal, just to show you what it looked like when we found it, here are the elements, the jugal, the dentary, and the brain case that came out of this in the outcrop. And you can just see a bit of the jaw and a couple teeth poking out. That stuff on the right is still to be prepared, but we do have preliminary results, and it looks like it's a complete but disarticulated skull. So in addition to this sort of Pseudasuchian Rawasuchid grade thing, or Rawasuchian grade thing, we also have a surprisingly large amount of theropod material. And that theropod material is exciting because there's never been a Triassic theropod reported from the Elliott Formation. The only stuff that possibly was attributable to theropoda are a few isolated teeth that my student Rick went and reassigned to Rawasuchia a couple of years ago. And so this was pretty exciting to find these theropods. And here I've just got a few numbers corresponding to what the material actually was. It's basically a couple large theropod femora. We've got another tibia that just came out of the prep lab last week, but I've been away, so I wasn't able to show you that one. Bit of a skull, a partial articulated pes with beautiful articulated phalanges, and then some smaller theropod material that seems to be associated but not perfectly articulated. And that stuff looks like this. So on the left-hand side, we've got a partial maxilla and a partial dentary, an anterior cervical vertebra, and then you can see you're looking in dorsal view at the top of the back of a theropod skull that has very deep supratemporal fossae, a big nuchal crest, super long exoccipital or paroccipital processes, and many of those features either look autapomorphic or at least appear to be a unique combination of features. And they probably placed the thing that owned this skull somewhere close to Zupaisaurus on the tree. So quite low down on the theropod tree among coelophysoids. We've got, moving to the right and sort of almost towards the center, we've got a highly sigmoid femur. It's very gracile, and a tibia that appears to go with it, a much larger foot, and then some really big femora. These femora, if you use the Campione and Evans math, these three femora on the right end up with theropods that weigh in excess of 100 kgs, which for the Triassic is quite heavy. And we're delighted to find these animals in the same bone bed as a large Rawasuchian, which suggests maybe that Rawasuchians at least weren't completely competitively excluding theropods from carnivorous niches in the late Triassic. And there's also some articulated caudals, of which more keep appearing, which hopefully will reassemble themselves into most of a tail. Of course, it's the lower Elliott Formation, so you're going to find sauropodomorphs in there. And we do, at the very bottom of this quarry, we do have a large sauropodomorph in disarticulated but associated condition. And that material looks like this. It's got a pretty robust femur and tibia, a very, very bowed ulna, and a short forearm, and we've got a few bones of the foot and a couple vertebrae. So watch this space. That one hopefully will keep assembling elements for and have diagnosable and relatively complete animal by the time we're done prepping stuff. There's also from this same quarry a bunch of mystery material. And I hope you're getting a sense of just how many animals are in there. And these are things that, because I did a PhD on middle Jurassic theropods from China, I never saw some of this kind of material in my comparative collections visits. And that includes like these weird distal femora that are highly bowed. They're very expanded and rugose, and they lack prominent condyles on the end. That's the stuff on the left. Then there's some more gracile stuff, which looks to me quite a bit like a silosaur. On the lower right, sigmoidal, thin femora with small anterior trochanters. And then there's two pieces of pelvis, which we're pretty sure go to something like a poposauroid, and not the big articulated specimen on the upper right. And so that tells us we've got quite a diversity of animals here, at least 9 different species, all of which are going to be new to science. We don't have records of almost any of this stuff from the lower Elliott Formation. So tremendously productive quarry. And that's all the animals kind of superimposed on each other in their positions in the quarry, just to hammer that point home. So to shift from fossils, so the fossils are great. Everything's under prep now, and the first of these results will start coming out. We just had a paper out this year of showcasing a tibia from there, which we thought belonged to an early crocodilomorph, and I still think I could defend that. But in addition to the fossils, we called in the geology team to help us understand the age of these Comeja deposits. Now that is, it's always a bit contentious, in biostratigraphic correlation isn't as precise as we would like. And the approach that we chose was to sample quite broadly throughout the stack of sediments at Comeja and collect detrital zircons from many, many layers. And I've been working with Selena Suarez and Glenn Sharman at the University of Arkansas on that project. And what you can see on the left is our generalized strat column. This is work that was done initially by Pia Viglietti and Lara Shishio, with DZ samples marked on that in various places. And as our dates have come back, we've been able to get some what we think are reliable zircon grains and some very precise ID TIMS dates. And so that BB quarry that I was just showing you, the big bridge with all these cool carnivorous animals, that's bracketed by dates that are about 200, let's say 213.9 to 213.2. So just about 213.5 million years old, which places it right in the upper part of the Norian, and comparable to famous quarries in North America where the Chinle Formation crops out. And we'll be adding more dates as we go along. Some of these things are hot off the press, and I didn't have time to include them here, with the end result of having a complete strat column with dates at regular intervals throughout the whole thing. So as we're discovering new taxa, we know how old they are right away. We're also doing some work, and if some of you go to GSSA, you'll see Selena's talk on the chemostratigraphy, or Danielle Oberg's talk on the chemostratigraphy of this place, as well as some magnetostrat that's in the works being done by Lara Shishio and a guy named Mikhail de Kock here in South Africa. So we have some good age assessments. We know that these key deposits at Comeja are all going to be somewhere in the Norian, and maybe at the youngest up to the Rhaetian. Okay, so let me finish my thought here. In the end, what this does is by collecting lots of fossils, placing them in a stratigraphic context and getting dates for that entire stratigraphy, it allows us to really begin to test this hypothesis for the ETE. And I think it really is a hypothesis that a lot of Pseudotsuchians went extinct at the boundary, and then dinosaurs took over the ecosystem. And so I think as these animals are described from the fossils we've collected, we'll for one of the first times have a rich fossil record going from the Norian all the way up into the early Jurassic at a single locality. And I think that makes this place, Comeja, one of the most important sites globally for studying the ETE. I want to shift gears now and talk a bit about the other important stuff of paleontology, which is our public facing aspect. And this is the foreshadowing I did with the initial permitting trouble we had, which was that the permitting bodies really want you to see these scientific discoveries being leveraged for community development. And as a paleontologist, you don't get training in that kind of thing. And so we were very lucky in the early phases of the project to hook up with this woman in the center named Yoli May. And Yoli is a caterer and a host par excellence. She owns a storefront in the area, and she was able to accommodate our party and feed us hearty local fare. And in the course of the seven field seasons we've done in Kameha, she's grown from a person who made a plan on day one to a professional caterer who's grown her business to hire 2 Black female employees in the area on a full-time basis. And then she uses the sort of capital input from us to help her buy things that allow her to scale up her operations. So she's doing weddings, she's doing stuff by demand from local government. And it's really the interaction between helping our project and helping the community that's made her job and her business a success. So it's been a bit of a win for the local community. And it's very important, I think, if you're developing large projects like this, to think, can we get people to leverage their own jobs out of this? Can they build on what we're doing here and then go out and find other opportunities for themselves? And I think in this case, we've done that. The other thing that we've done is we've always had an open quarry policy. So anyone in the community can stop by a quarry anytime they want, and we all basically will drop tools and let people try stuff out, point things out, and explain the science to them. And in the initial phases of the project, this could mean every day you got 10 or 15 people coming by and sort of asking timid questions about what you're doing. But all those people left satisfied, and I think word spread. And because of that, the community, who's at least 1,000 people strong in the area, they all know us, and the local police officer waves at us, and people are happy when we come to town, and they don't think that we're there stealing things or digging up the graves of their ancestors or something like that. And that really has been a concerted effort on all of my team's behalf to just make sure we speak to the community and we tell them in plain English what's going on. We've also tried to give back to the community with a bunch of sort of targeted, I don't want to call them interventions, but targeted activities that try to explain our work in an accessible way. And one of the ones I'm most proud of is we built in conjunction with Genus, which is the South African Center of Excellence in Paleosciences, and an NGO called Play Africa. We built a traveling exhibit that it gets children, young learners, so people in kindergarten to sort of age to grade 6, to interact with dinosaurs and other extinct life through the process of play. And so on the left, you see student Brandon Stewart in our department. He's playing with dinosaurs in a diorama with local school children. My student Chandler Montgomery on the right has put on a dinosaur suit and is scaring local school children. But these have been so we did this educational outreach, and it was a tremendous way to get tied into the local educational community. That outreach then came back to Joburg, and we had it on display here at the Children's Museums for a number of months. And so we try to do some sort of interaction like this each year. Sometimes it's just a community braai where we give a short lecture or a speech and people can show up and ask questions. But this is another way to get community wins out of the project. And that's not to say that aspect of the project hasn't been without its ups and downs. In the early days of the project, it wasn't just the regulatory body that took notice of us, but it was the local politicians, because it's a big, exciting project, and foreign researchers are coming in, and there's stinks being made in the BBC. Local politicians said that they wanted in on this, and they wanted to try to help in their political way make the scientific successes political successes and leverage additional funding and opportunities for the community. And so there were some pretty disruptive things that we had to do. We had to, host events at quarries and try to get things tidied up so people weren't stepping on sharp tools and so forth. And in those local politics in the early phases of the trip took incredible patience from everyone, and probably on their side too. But the upshot of that was extremely rewarding. So on the right, we are signing a memorandum of understanding with all of the local stakeholders. That includes tribal officials, it includes the Eastern Cape government, it includes municipal government and local leadership. And that MOU is a handshake agreement that basically says WITS University and the researchers involved in this project will work as hard as they can, not only to promote the great science, but to really to leverage that science into growth opportunities for the community. And so that's been formalized now, and I think as a guiding document for how we go about doing research, it's been tremendously beneficial. For example, recently we were able to get an enormous, a whole pickup truck full of donations of toys and clothes and books for local creche children. So these are children who are just about to enter kindergarten, and as you can imagine, in these rural areas, the budget for books and the budget for toys is very, very low. And so we through just hitting our networks in Johannesburg and in London and in the States, we're able to get this huge donation of toys and books, and we're able to spread it out amongst several creches in the area. Okay, well, that's kind of the end of my talk. That explains this project that I'm so proud of in a very topical way. But we've got some big next steps for science. So we got some amazing specimens. On the left is the fully articulated sauropodomorph. There's more jackets that go onto this thing. That's a fully articulated new species of sauropodomorph that has yet to be studied and is currently being undertaken by a PhD project. And on the right, this is prepared in our department, Mabuti Lo, who's holding the femur of a giant pseudoseuchian, in fact, that articulated one with the skull. So the next steps for science are really the bog standard paleo stuff, right? Prep, describe, and publish. But they're going to be pretty exciting, and I hope you people in the audience who took an interest in this keep tabs on us, because the next few years should show you some great fossils. And then there's also next steps for the community. That area has tremendous scenic beauty. In March this year, I went out on a special trip to help them think about how do we leverage tourists, not just for the paleo, but for the other incredible natural scenery. And so I'd always come in as a scientist, and I'm like, I want to dig my holes in the ground, and I want to get my fossils out and get them back to the lab. What we went down this time is a bit of tourists, and we're shown incredible local rock art. These are a bunch of eland, although you can't quite see their heads. The white pigment has worn off the cliff, and things like pristine rock pools, great hiking trails. And so the next steps for the community are really to work with us to publicize and leverage those things so that they get tourism all year round and continue to sort of build on this preliminary model we've assembled. Okay, with that, I think I'm about right on time. I really wanted to open up the floor to lots of questions. If you've got questions about the science, or questions about how do you set this up, or questions about whether or not we're doing the right thing, I'll take them now. But I need to say a special thank you to all my funders. And of course, all the people involved in this project, students and faculty from around the world. But particularly the people pictured here, these are our technicians in our preparatory facility. And the technicians so often don't get acknowledged on papers or on talks. And without their help in sort of solving some of these logistical issues, like how do you prep a 1-ton jacket? Without their help, we never see a single thing. So I wanted to give a special thanks to them. And with that, I'll turn the talk over for questions for the next 15 minutes. If no one has questions, I'm incredibly jet lagged from my last 24 hours of travel back from the States. So I'm happy to just leave it there. And you can email me questions. I'll type my email into the chat. I was at the start of the talk. And I can try and answer your questions over the written communication if you prefer.
Hey, Jonah. It's
Hi.
I don't have a specific question, but it's Karen Poole. Hey.
I figured your face is on my screen. It's nice to see you, Karen.
It's yeah. It's great to hear a little more about what you've been up to, and yeah, that's all. Like I said, I didn't really have a question, but since no one's chiming in, I figured I'd say hi.
Cool. Well, thanks for the super easy non-question.
More of a comment than a question, really.
Good. Oh, thanks for listening.
Yeah.
Jonah, I'll ask one for. Oh, let's see. We've got a question down there. I'll
Yeah,
hold mine
I
off.
can. I've got them. So I can just answer them. I'll just answer them in order. Romy, we used uranium lead dating on those zircons. That's that in what we initially did was a round of LAICPMS to get suitable crystals that are showing young ages, and then we refine the precision with subsequent ID TIMS dating. So that's uranium lead series stuff. Mickey, in answer to your question, Mickey, the theropods S in 1 through 3, they do have specimen numbers yet, and they do have specimen numbers rather. And the only one I can think of off the top of my head is 8483, which is that large femur that was in 2 pieces that you saw. But they will they certainly have specimen numbers, and they'll come out as they're described. Justin, thanks for the comment. The community involvement is a must in the project, and it's sort of, we've been playing it by ear, and I'm not sure we got everything right, but I do feel proud of the progress we have made. Eric, this related question. So were there any situations where local politicians conflicted with a project, or were they mainly approving of it? And actually that's a really good question, because it was not uniform approval. And there's certainly people just in the local community we had to win over and say that we weren't there mining diamonds, and that these fossils really have no legal commercial value in the South African context. That's kind of one of the conflicts. And even at a recent meeting where I was talking about all the progress, I was heckled by a guy, and I felt his pain. He said, where are all the jobs? Where's the clinic? Where is the development that you're speaking about, that you're trying to foster? And I don't have a good answer for that. I mean, you have to be patient. My response to him was, I do the best I can. And this is not just scientists who have to do this. Obviously, it's your local political community. There was also a series of, let's call it a series of negotiations in the initial phases of setting up that memorandum of understanding. And those were due to the fact that many different people claim the land. There's communal grazing rights in that part of South Africa. And there's sort of quite a long and very tawdry history of people being forced off of land, forced resettlements, and then subsequent land claims, as well as uncertain property ownership in deeper history. And I think that some members of the community felt that their land was being taken by them, from them, by politicians saying, yes, it's okay to dig here, or yes, it's okay to dig there. And this is where the community pioneers really came in. I mean, they're incredible for so many reasons, but one of the things they were able to do is take the time necessary, like at the grassroots political level, and find these people who had objections and say, look, here's what we're really trying to do. Here's the benefit to the community that we foresee. And they could vouch for me as a scientist and as a person who's interested in establishing good relationships. And so that's that patient politics that I was talking about. So there have been some conflicts, but on average, almost everyone you talk to is just like thrilled about this project and really approving of it, and obviously wants it to continue.
Hey, Jonah, it's Selena.
Hey, Selena, how you doing?
How you doing? I'm doing good. Hope you're doing well.
Do you want to answer some of Roby's questions for me?
What, the dating questions?
It's cool.
Yes. Yeah. So the question about shrimp. No, it wasn't shrimp. It was LAICPMS to kind of isolate the young population, and then chemical abrasion ID TIMS to get the more accurate, higher resolution date.
And Selena, that's pretty much that's the best you can do right now. Is that right?
Pretty much, yeah. I mean, I think shrimp microprobe can get pretty accurate as well.
Okay.
But yeah, like ID TIMS is pretty much the gold standard right now for high resolution chemical abrasion ID TIMS. Or high resolution dates, high resolution dates. Again, maximum depositional age dates, but dates nonetheless.
Yeah, that's right. I should have said that. They're not real dates, right? They're like
they're
hypotheses.
that age or younger.
Yeah,
But when
that-
you have a stacked series of them that young upward, you can, and when the grains themselves are kind of needle-like and not highly abraded, it would suggest that they are close to depositional age. And then hopefully we'll get some chemostratigraphy through there and use some carbon isotope chemostratigraphy to kind of tighten up those age ranges. So I had a quick question for you though, which
fire
was
away.
I briefly talked with Roger at SVP, and he said something about a site with lots of shed sauropod teeth from the lower Elliott. Is that at Big Bridge or is that somewhere else? Or maybe
With
he
lots of
didn't say lots.
lots of
Sauropod.
podomorph teeth.
Yeah, sauropodomos teeth. Maybe it wasn't lots.
Yeah,
Oh, Kimmy
there
says
are,
ZZ Top.
yeah, there are, yeah, ZZ Top, right? So I didn't get to include that one in this talk, but we've got a site that's right on the boundary. It's so it's we're actually Amateur thinks it might be Upper Elliott, but it may still be Rhaetian. We're not quite sure. I don't have dates from there just yet. But ZZ Top is like a microsite, and it does have lots of shed sauropodomorph teeth, as well as possibly ornithischian teeth, and certainly some carnivorous thing. It's probably theropod teeth.
Okay, cool.
Yep.
Right on the
And
boundary. That's cool.
yeah, it's right on the boundary. I think it's quite cool.
Okay, cool. Yeah, we should chat. I need some more plant eaters from the lower Elliott formation.
Cool.
to slightly damage and analyze.
Yeah. Okay.
We'll talk
We'll
about
have
it.
a side chat. Cool.
Yeah.
Madeline, can I answer your question about fossil poaching? It's so any concerns about fossil poaching is your question. And I worked in the Elliott Formation for 10 years, or 11 years, and I've done all kinds of field work, and I've only ever had a single fossil removed from a site. And it happened a long time ago. It happened on my more or less the first set of field work that we did here. And so we've had very good luck with fossil poaching. Although occasionally some curious people will stop by the site and poke at things and dislodge them. Luckily, we've been able to glue that kind of stuff back together, but it's still very, very rare. And interestingly, in the fossil poaching case, it was certainly a local person. They took a piece of a femur, and we called the police about this, and the police were really responsive, like amazingly responsive. And they sent out an investigator, and this investigator is like kind of a hard-boiled old towny looking dude. And I thought, oh geez, he's just going to blame this on local farmers or local herdsmen or something. And to be fair, like, he spoke 3 languages fluently. He could speak Zulu, he could speak Afrikaans, he could speak English, talk to everybody. And he said it's probably a local farmer who wanted to put it on his mantelpiece. And although we never got it back, it was taken very, very seriously. So I'm not too concerned. We certainly, that full court press of politicking by the community pioneers includes lessons about, like, we will never pay you for fossils. The fossils are worth more in the ground to scientists than they are brought here or sold on the open market. And so far,
Yes, 2 seconds.
Catherine, you asked about any possibility of microverts in the area. I kind of side answered that with Selena, but my student Bailey discovered a site right on the upper Elliott, lower Elliott boundary, and that site has lots of micro stuff. We've gotten a few mammaliomorph small jaws and teeth out of there. We've gotten like we just said, a number of sauropodomorph and probably theropod dinosaur teeth, and we're actively collecting that. Our first plan had been to just hack it out and sieve it. And then as we cut in, we started to find things that looked like they might be more articulated. And so now we've taken a big lens of this sort of microvertebrate bearing locality, and we're going to jacket the whole thing, and then figure out how to get it off of this hill. And once we've done that, figure out exactly how to prepare it. So, yep, we'll have some micro stuff to show you soon. Alrighty. Well, any
Jonah,
other questions?
I actually, the question I had was about your the site where you were taking stuff out with a crane. I was wondering if you could go back to that slide real quick.
Sure. Let me just start the show again.
Oh, okay.
No worries. I see a crane. Oh, there it is. Yeah, let me start that, and then I'll share my screen. Sorry, I'm completely inept at Zoom. There we go.
No worries.
Okay. Share. Yeah, so this is the Big Bridge locality. And really if you're looking at the Big Bridge, it's the spot I'm standing on is where we're digging there on the left. And then here are the jackets we isolated from there, and that's crane moving them. So what is your question?
So my question is, you're talking about lifting all of this stuff out and driving it back. I guess I'm just curious how you managed all this. What steps behind the scenes do you take to minimize jostling and fracture and otherwise damaging things? Like this is an awesome setup, but it seems like there's still a lot of kinetic risk involved.
Yeah. And the first object that we lifted in this way, people couldn't look at it being lifted because they were so terrified it was going to snap. There's another picture I have of that exact thing happening. So we've never actually broken a jacket this way, I should add, but there's a couple things we do. One is we really overbuild these jackets. So they have sometimes up to 14 layers of plaster and burlap on them. Gotcha. And burlap has incredible tensile strength. So we use it to, double or quadruple layer of burlap, and you can carry 400 kgs out of the field as long as you can find enough people to lift the edges. It doesn't break. So it's got killer tensile strength. And then when you put enough plaster on it, I think you've got a nice heterogeneous material that resists warping, which would be the big thing. That would really smear stuff, and then resist cracking. This year, we had Nick Campione and Phil Bell out from Australia, and they gave us some tips about putting rebar into these jackets. It's something that Joe Sorge, a few other people had suggested to me as well. So a couple of these jackets, I think almost all these jackets that you see here have bundles of rebar that have been bent and sort of strategically laid to give it a little bit more resistance to flexing, which would be the big problem. And then these cranes are the operators are unbelievable. That guy can position a fossil in the bed with centimeter accuracy. It's just amazing. So the good operator helps. And then do you see this? You see that blue and yellow thing? Those are
tires.
I
was wondering about those.
Those are painted tires. And this is high tech. This is high tech, cutting edge field stuff that I think we discovered or we pioneered, which is to flip specimens onto tires, and then they're going onto tires in the bed of the truck. And those tires are great at isolating vibrations. And they also deform enough to allow you to kind of slowly lower something down into the pocket formed by the inside of the tire itself. So that's a hot tip for my 2023 field season is get lots of old tires and bring them around with you.
No, that's super clever. I work with big jackets occasionally with my high school groups here in Kansas. And that's something we've had to deal with is how do we haul these things in the bed of a pickup truck out from a little canyon through a field without just jostling them into powder.
Yeah.
And tires are a prevalent, I feel like old tires are a relatively easy resource to access.
They skid pretty well too. They actually kind of creep along relatively smooth surfaces like grass and things. You can move the jacket pretty well on them. So I'm trying to think of anything else. We're gonna Roger Benson told me he was out in the field in Wyoming, and those guys use T-bar as their rigidity providers. They don't use rebar, but it's that T cross section, and that stuff is incredibly good at resisting flexion. And that might be a good avenue. It's relatively light.
I want to emphasize for folks in the audience that obviously we have our itinerary set for the virtual meeting this year, but for next year, if you know of work being done like this it's a bit of a longer form talk, it's not going to fit into a 15-minute space as far as this narrative. Field work, community engagement, engaging with regional and local politics, this is hitting all these really important things that we need more attention to in how we're talking about how paleontology gets done. Come talk to me. I would love to see more talks like this next year that are in like the 30 to 40-minute range, where we can really get our hands deeper into these examples and into these stories.
David, I see there's one more chat thing. Okay. All right. Yep. Cool. I got it now. Okay. Looks like I answered all the chat questions. Well, anyway, I'll just end by saying thank you everyone for your patience, and I'm glad. Thanks, David, for the compliment there. None of this stuff, I don't actually know the answers. I feel like we're flying blind most of the time, but so far stuff has worked out quite well, and I hope it continues to. And my pleasure speaking to you guys, and hope to see you in person next year, maybe.
Yeah, and I'll agree with one of the comments in the chat here. Having more of these long form talks is definitely a goal. Just need to find people that have something that kind of fits what we're trying to do here. But please let us know. We're looking for ideas. And thank you. I think it was Kimmy Chappell, who brought this idea to have you present. So thank you to her for facilitating that.
Yep. Thanks to her for inviting me to do it, and thanks to you too.
All right, I'm going to shut off the recording. Thanks everyone for coming. We've got more events happening later today, both networking socials, which I really encourage folks, if there's something you're interested in on the networking socials, contact other folks you know who have access to the virtual meeting, who we saw in person. Let other folks know these things are happening. The networking socials are really only as good as the number of people that are showing up. And that'll really help make those events a lot more valuable for everybody involved. With that, we will shut this down. Thank you all again.
Yep.
Take care.
Cheers.